Okay, for this unit we have a lot of different key terms for angles and parallel lines, so I'm just going to go through each of these terms. So point is a precise location on a plane, usually represented by a dot. So we would point. A line is a geometric object that is straight and infinitely long and infinitely thin. We draw lines like this. A line, the arrow means it goes on forever in both directions. A line's segments are all the points between 2 points, including the points themselves. So a line segment is like a point and then a point. And really when we talk about a line, what it really is meaning is that if you were to put a dot on every single point, like infinitely, between 2 points. That's what a line is. It represents every single point it could possibly be. And we connect them to just show that it's all of those points. Because you're always going to have a smaller point, right? Because numbers are infinite. Okay, a ray is a portion of line that starts at a point and then it goes on forever in a different direction. An angle is 2 rays or line segments that meet at a point called a vertex. So it could be like this, or it could be like this with arrows. The arrows would mean it's rays, the points would mean it's segments. So the vertex is any time you get to a point. An angle measure, that's what we actually call angles, like how many degrees it is. So this is the angle measure. We often use theta to measure the angle, so that's called theta. An acute angle is any angle less than 90, so like that. A right angle is exactly 90. We show it with a square. An obtuse angle is between 90 and 180, so it would be like this. Okay, a straight angle is 180 degrees, so that would be like a straight line. And a reflex angle is bigger than 180 but less than 360, so we could say like that. We use angle reference. They're ones that we can easily sketch. And I'm going to do this in another lesson, but the ones that we use are often 0, 30, 45, 60, 90, 180, and 360. And there's different ways that we can sketch them. Complementary are 2 angles that add up to make 90 degrees. So like these 2 angles would make 90 degrees. That's beta. Supplementary angles are 2 angles that add up to make 180 degrees. True bearing is how we measure directions. They're measured clockwise between north and around. So we go like that. North starts here at 0 degrees and we end at 360. So again, north is 0 degrees. And then you measure around. Clockwise is how the hands on a clock would move, so it's to the right. Counterclockwise is the opposite. So we have 2 geometry tools that we'll be using. There's the protractor, so that's the one that we use to measure how many degrees something is, and then we have the compass, which is what we use to construct angles. A construction is the act of drawing a geometric shape. Congruent means it has the same shape and size, so if I have 2 congruent angles, I would denote it like this to show that they're the same angle. Bisect means to cut something into 2 equal parts. So if I have an angle and I'm bisecting it, it would cut it in half, making both sides equal. So that's what an angle bisector is. Same thing. Perpendicular lines cross each other at 90-degree angles. Parallel lines are 2 lines that will go on forever and never meet, and the way that we denote it is with like a little arrow like this to show that they're parallel. Non-parallel lines at some point will cross. You can draw it all sorts of ways. A new term that we probably haven't used is a transversal. So whenever you have two lines, they don't even have to be parallel, but let's say they are. Doesn't matter. This is the transversal. It's where it crosses two or more lines. Okay, and the last examples here, these are, we're going to go in depth in these on lessons, but these are kind of some of our rules and laws that we use. So this is a good place for you to have them so that you know where to find them. So first one is corresponding angles, and I like to think of angles as they're in the same location. So if I said this one, it's in the top left-hand corner, it's the same as this angle right here. And they're the same, they're equal because they're corresponding. So let's label this actually. 1, 2, 3, 4. Corresponding on here would be 5, 6, 7, and 8. So those are our corresponding angles. So 1 equals 5, 2 equals 6, 3 equals 7, 4 equals 8. So those are our corresponding angles. The next one is vertically opposite angles. So this one would be like 1 and 3. They're across from each other. So 2 and 4. 1, 2, 3, 4. So the ones that are across from each other will be equal if it's vertically opposite. Alternate interior. So the word alternate means on the opposite side, and interior means the inside. So if you think about like this is the inside and those are the outsides. So the way that it works is if it's on the opposite side, so 1, 2, 3, 4. Those are our equal sides because of alternate interior. Alternate exterior, same concept. So this one would be 1, and it would equal the one on the opposite side of the transversal on the outside. So these two would also be equal. Same side interior angles. So if I said this is 1 and 2, what I know about same side interior angles is that when I add them together, they're going to make 180 degrees because they're supplementary. And it works the same with same side exterior angles. And that is all of our definitions. This we'll deal with later at the bottom.